here is our next problem. Let's construct a quadratic function so that f of x minus 4 is equal to f of 2 minus x, and that f of x is greater than equal to x, and when x is on the interval from 0 to 2 non-inclusive, f of x is less than or equal to the square of x plus 1 over 2. And f of x must have a minimum value of 0. After we construct this quadratic, we're also told to find the largest value of m that is greater than 1, so that there exists f of x plus t is less than or equal to x when x is on the interval from 1 to m. So that was a very wordy problem, but they also gave us a lot of conditions. So let's break it down and talk about each condition one by one. The first condition says that f of x minus 4 is equal to f of 2 minus x. This is essentially saying that f of x is symmetrical about the line x is equal to negative 1. And since we're dealing with a quadratic, it means we're dealing with a parabola. The x value of the vertex of the parabola, now we know, is negative 1. And that is equal to negative b over 2a. So now we know that b is equal to 2 times a in our function. And from the fourth condition, it says that f of x must have a minimum value of 0. Well, we know that a parabola can either have a minimum value or it can have a maximum value. If it says that there exists a minimum value for f of x, it means our parabola must be opening upwards. So now we know that the vertex is negative 1, 0. The minimum value is 0. Now let's substitute negative 1 into our function. If we do that, we'll get a minus b plus c is equal to 0. And now let's look at our third condition. When x is on the interval from 0 to 2, non-inclusive, f of x is less than or equal to the square of x plus 1 over 2. Now looking at condition 2, we see that if we have x is equal to 1, then 1 must be less than or equal to f of 1. And from the third condition, it also says that f of 1 must be less than or equal to 1 plus 1 over 2 squared, which is also 1. This tells us that f of 1 is just equal to 1. And now when we substitute x equals 1 into our function, we get that a plus b plus c is equal to 1. So now we can solve for the values of a, b, and c to construct our quadratic. We already have 3 equations. B is equal to 2a minus b plus c is equal to 0, and a plus b plus c is equal to 1. So let's represent everything in terms of a. B is equal to 2a is equal to a, and c is equal to 1/2 minus a. And we are left with the solutions. A is equal to 1/4, b is equal to 1/2, and c is equal to 1/4. So now we know what f of x is. F of x is equal to 1/4 x squared plus 1/2 x plus 1/4. Now we have to find the largest value of m that's greater than 1, so that there exists f of x plus a value is less than or equal to x when x is on the interval from 1 to m. From looking at this interval, we see that the value x is equal to 1 is definitely in it. So let's explore what happens when x is equal to 1. When we substitute x for 1, here we also use the inequality given to us here. We're solving for t. From here we see that t times t plus 4 must be less than or equal to 0. So t's value is from negative 4 to positive 0 inclusive. Now we have the range for the value of t when x is equal to 1. Now what about the other extreme end of our interval, when x is equal to m? Let's substitute that in as well. we're going to apply our inequality again, which is the inequality f of x plus t is less than or equal to x. We're left with this inequality. We can further manipulate this inequality into a form that will be helpful for us. Now, we can look at t plus 1 as a whole and make our inequality to look like m plus t minus 1 squared is less than or equal to t minus 1 squared minus t plus 1 squared. So when we simplify the right side, it's the same thing as negative 4t. Now we're going to try to isolate the value of m. m plus t minus 1 is between two values, the positive square root of negative 4t and the negative square root of negative 4t. And now we're going to add 1 to all sides and then subtract t on all sides to get m is less than or equal to 1 minus t plus square root of negative 4t. And this is what we have on the other side. Here we have a very useful inequality. It helps us limit the possible values for what m could be. Let's observe. We see that as t increases, this expression decreases. And this is the upper bound of m. We want the upper bound of m to be as high as possible so m can reach its maximum value. This means we have to take t's smallest value. So what was t's smallest possible value again? We found earlier that t has a minimum value of negative 4. So we'll have to set t to negative 4. Now let's substitute this in for our m. This means that m is less than or equal to 5 plus 4. M is less than or equal to 9. And taking the maximum possible value of m can be 9. Now we have to check, can m equals 9 exist even? So going back to our original question, it says that find the largest value of m so that on the interval from 1, m, in this case 9, there exists f of x plus f of x minus 4 is less than or equal to x. We have to substitute in x minus 4 into our function. That's equal to 1/4 times x minus 4 squared plus 1/2 x minus 4 plus 1/4, which is less than or equal to x. Now we can further simplify. X squared minus 10x plus 9 is less than or equal to 0. And when we factor, we see that x minus 1 times x minus 9 must be less than or equal to 0. So the values of x range from 1 to 9 inclusive. As you can see, this confirmed that on the interval when x is equal to from 1 to 9, t is negative 4. So it does work, which means that m is equal to 9 in our answer.